Good morning, friends. Now we are going to discuss about Shannon Fano coding, which is one of the most popular technique used in information theory. So coding techniques, basically two familiar coding techniques are there for solving the problems in the information theory. The first one is the Shannon Fano coding, which we are going to discuss now. The second one is the Huffman coding. The first one, Shannon Fano coding. So the problem, whatever the given problem, list out the probabilities. We are going to see the problem in the next slide. Whatever the probabilities we are having, already we know that from the previous class, the sum of all probabilities, equal to 1. We know this one from the probability random theory subject also. So the list out, first of all we need to check the number of probabilities. Given probabilities, summation is equal to less than or 1, less than or equal to 1. First list out the probabilities according to descending order or decreasing order. So first the top will have highest value 0 0.4, 0 0.2, 0 0.2, 0 0.1, 0 0.1. So you can name the values A, B, C, D, E, F, or else x1, x2, x3, x4, like that. Okay, no problem. So then we want to partition these one into two sets, like two categories. The first one category and the second category. First category is a 0 category, the second one is a 1 category. How we are going to split up means equiprobable. So for example, like I said, sum of all probabilities equal to 1, 0.4 plus 0.2 plus 0.2 plus the remaining 2, 0.1, 0.1. You can able to split, we can able to split into half, but that possibility won't come here. Why? Because the first two, if I add, it will become 0.6. If I add all the remaining 3, 0.4 I will get. You can take like this, or else 0.4 I can take as one category, and the remaining all the things together 0.6 I will take another category. People can do in either way. I am taking the first method. The top 2, 0.4 plus 0.2, 0.6 I am taking as a first category, which I assign the first category with 0, symbol 0. X1 is assigned with symbol 0, x2 is assigned with symbol 0. The second set, which gives the amount, summation amount 0.4, I am assigning one symbol. For the three symbols or messages, I am assigning 1, 1, 1 in the stage 1. So we are assigning 0 for the upper set, 1 for the lower set. In the next cycle, this is the stage 1. Repeat the same process until you won't get any other further messages. I am repeating the same process as stage 2. Already we performed stage 1 here, but the same message stage 2 we will perform. So stage 2 should perform for stage 1. The base is stage 1. So whatever we have values, two symbols in the stage 1, the summation is 0.6 we know. Half we have to decide. Equiprobable we want to divide. So equiprobable won't happen. So the upper one is 0.4, the bottom one is 0.2. So we can split up into two parts. The upper part I will assign with 0. The lower part, lower category, I am assigning with 1. So this stage is over for the upper boundary of stage 1. The lower stage, lower category, for this lower category I want to split into two halves, two equiprobable. So here the value is 0.2, 0.1, 0.1. So how can I split here? The top probability is 0.2. I will put like one category. 0.2 I will take it as one probability and assign 0. One category, upper category. The lower category I will have 0.1, 0.1 as assigning with 1, 1. So among the three values 0.2, 0.1, 0.1, the upper one I assigned with 0. The lower category, two symbols I assigned with 1. So this is stage 2. Up to here stage 2. So we should repeat the same process for stage 3. Stage 3. If we come for stage 2, here no further probabilities. Here 0 and 1. That's it. We are not able to split up into 2. So that's why leave this one here. And here coming to here, this one is 0. We can't split that one into 2. Here in this category, 2 1s are there. We can split that one into other category. So like we did previously, the equiprobable, the upper category assigned with 0, the lower category we assign with 1. That's it. Hereafter we can't proceed for the stage 4. The splitting of the sub individual groups ended here. So now list out the code word, or write the code word combinedly. So for the symbol which is in the first row have 0 0. If you accumulate all these symbols, 0 0. For the second x2, 0 1. For the third row, 1 0 1 0. Two things I am combinedly writing and rendering as a code word. And the fourth row we have 1 1 0 1 1 0. That one I am writing as a code word 1 1 0. The last row we have triple 1 1 1 1. I am writing as a code word 1 1 1. Now take the other column and one more column which gives number of bits in the code word, either zeros or ones. You can say it as code number of bit. In this code word 2 bits are there, in the other code words 3 bits are there. List out that one and name it as message. Number of bits per message ik, number of bits is ik, and the probability is nothing but p suffix k. So these two terms only it will be useful while solving the problem and finding entropy and other values like average length. So ik is the number of bits per message, pk is the probability for each event. So this is the thing what we did the table, how you did the table for Shannon Fano coding. So people used to give problem like this: a discrete memoryless source having symbols x1 x2 x3 x4 x5 with probabilities, list out respectively. So they will ask us to find out efficiency, coding efficiency for the source code, Shannon Fano code. For the source, what is the coding efficiency, how efficiently it is producing the code. In order to find out efficiency, we need average code word length and entropy. Without ik value and pk value, we are not able to find out that one. That's why we need to perform this table what we did in the previous two slides. I have two values. We have two values, probability pk and message bits, number of message bits ik. How can I find out average word length L? Average word length L is a formula given by summation k equal to 1 to k, pk into ik, probability into information. So how many number of bits per message ik? 2 bits. So here 2 bits into that particular probability 0.4. So the row 1 0.4 probability multiplied with 2 number of message bits, plus as we are having summation, we should add up all 5 instants. As we have 5 message symbols, k equal to 5 here. So 5 amounts has to be summed up. So 0.4 into 2 and 0.2 into 2, the third row 0.2 into 2, fourth row 0.1 into 3, and the last one 0.1 into 3. So which we will get 2.2 bits per symbol. Average word length means 2.2 bits per symbol. So one thing we have 2, one thing another we are having 3. So average on our average 2.2 bits per symbol. Now I got L. Next the task is to find out entropy. Entropy is a well-known formula we already studied in the previous class. H of x entropy is defined by symbol h of x is given by pk log 1 by pk, where logarithm base is 2. So we need to sum up all the instants. So how many instants will come means how many message bits are there? 5 message bits are there. So 5 instants will come 5 times. So pk log 1 by pk. The first probability is 0.4. 0.4 log 1 by 0.4. 0.2 log 1 by 0.2. So for the last 2 also we will do like this. 5 times will come for 5 messages. If we calculate in the calculator, we will get 2.12 bits per message per symbol. 2.12 bits per symbol. This is the entropy. So if we know the entropy and the average code word length, I can calculate efficiency, coding efficiency. H of x by average code word length L bar is nothing but efficiency. So we have the value of L 2.2 bits. This one is 2.12. If I take the ratio according to this formula, I will get 96.45 coding efficiency. 0.9645 means nothing but percentage of efficiency is 96.45. If I want to know the code redundancy, comma, I want to subtract the efficiency from 1. 1 minus efficiency is nothing but coding redundancy. Repeating redundancy. 0.035 is the redundancy. So in such a manner, we are going to do the Shannon Fano coding for the given problems, probabilities. Thank you.